right, so this is the first kind of problem that I stepped into with these about 5-6 years ago when I realized that this was the direction the Regents was going to go, and where they were going to have to do a combination of these. And I couldn't really figure out exactly what was going to happen, but I knew it had to be some where you were adding the triangles together. It was actually the first thing I thought of. I didn't think of the subtracting part until after that. So anyways, got a man on a cliff. He's looking at the top of a tree at an angle of elevation. All right, so I've got my whole logo line that I usually have. So I've got a tree over here on the side. I'll highlight it in yellow for a second. So there's the tree. Okay, the cliff is over here. So there's the cliff. This would be the ground down here. So that's what I've got going. Okay, so I label all this stuff for you. This is a pretty complicated picture to draw and get so it's correctly. So I'm worried more about can you do these with the picture there. Okay, so where are our right triangles? All right, let's get those things. So here's the right triangle right here. And then here the right triangle right here. So there's my two right triangles. Okay, the stuff's all labeled. It does give you, it says the angle of elevation is 15, angle of depression is 36, so we're clearly in the right spot. The tree is 25 feet from the cliff. It wants to know how tall the tree is, so it wants to know how far is it from there all the way to there. That is not in any of the right triangles, but I can find that X side from the yellow triangle, and I can find that Y side from the blue triangle. So what I'm going to do is I'm going to do X plus Y, and that's going to give me the tree. Okay, so we cannot always subtract. We have to make sure that we're thinking about it logically and trying to figure out what's actually happening. There's an angle in here. And that means it's going to almost definitely be a circular problem. The nice thing about these is the triangles aren't overlapping, so it's usually much, much easier to deal with where the hypotenuse, opposite, and adjacent is. So in the yellow triangle, they're right there. So like the rest of these problems, and I think they all are like this in this file, there's the adjacent, there's the opposite. So this is another tangent problem. So tangent equals fraction, the adjacent is 25, the angle is 15. I don't know the opposite. Okay, so I'm going to cross multiply this after I get tangent of 15. So tangent 15 is 0.267. So 0.267, blah, blah, blah. Cross multiply these. So that times 25, 6.698. So x equals 6.698, blah, blah, blah. Okay, now the blue triangle, same deal. Hypotenuse is over here. Opposite is over here. Adjacent, the 25 of them. I want to know the opposite. I know the adjacent, so this is another tangent problem. So tangent is fraction. The adjacent is 25. The angle is 36. I don't know the opposite. I know the angle, so it goes over 1. Tangent 35. 0.700. 0.700. Cross multiply, and I get x equals 17.505. 17.505, blah, blah, blah. Now remember, we're going to add these together this time to get our answer. You know what? So that plus that. 24.203. 24.203, blah, blah, blah. It says how tall is the tree of the nearest foot. That means no decimals.